Hello team, today's challenge is exact change where we're given an integer, a number, and we need to figure out how many different ways we can make exact change using pennies, nickels, dimes, and quarters, which is kind of weird because up here in Canada, we don't have pennies anymore, but we're still going to give it a try. The simplest one is anything less than 5. There would only be one way to make change. It would be all pennies, right? Whereas with 9, we could use a nickel and pennies or all pennies. That would be two different ways, right? And so on, etc., until we get all the way up here. Apparently, 213 different ways to make 99 cents. So, kind of interesting. No reason to go over 99 cents because 100 would be $1, right? We would be into bills at that point, or large coins if you're up here in Canada again. So, hooray us. With this, this is a classic problem. It's been worked to death, and you can go and find pretty much the exact same solution. No matter how you search this, you're going to see something that is very similar to what I show today. The difference, hopefully, is that I'll explain it along the way, which will help you understand it instead of just possibly copy and pasting that code and calling it a day. Okay. Because being able to understand it is really the point of these challenges, right? Getting that thorough, deep knowledge of what the code is actually doing. With that, we are going to jump over here and start. Now, for this, we need our coins, okay? The coins in this case are 1 and 5 and 10 and 25, right? Those are different denominations for the coins, right? Pennies, nickels, dimes, and quarters. And then with that, we are going to create a new array. And this new array is going to be a place where we get all of the different variations for everything from 0 up to and including our amount, which is a little bit weird. But when I explain it, hopefully it'll be less so. Okay. So we create that array like this. I'm just going to call it array for today. And let's call it new array of amount, spelling it right, amount plus 1. Why amount plus 1? Because arrays are 0 indexed, right? So if we want to be able to get, say, 10, right? Well, the 10th index is actually the 11th item. So we need to add 1. That's where that plus 1 comes from. And then we fill it. So we can just tack on fill. We fill it all with zeros. And then we set the 0th index, the first index, to 1. Why 1? Because there's only one way to make 0 change, and that is with 0 coins, right? Only that one way. So right here we go array, setting the 0 equal to 1. There's also a small catch in here where if we don't do this, then none of the math that comes next works. So we're kind of making an assumption with 0 coins, right? Being one way to do it, which is no way to do it. But we'll let it ride. We'll talk about that in a second. And then from here, we iterate over the coins, okay? So as we iterate over the coins, we're going to see how many different ways we can do the ones. We're going to do all the ones. Then we're going to go to the 5s and see how many different ways we can do the 5s. And it all kind of happens magically, right? It's something called dynamic programming, I believe. This system that we're using today. So right here, we're going to grab that coin. It's going to be of coins. Excellent. And inside of here, we drop right into another loop, which is let I equal coin. This is important because this saves us from, like, when we get into 5 or 10 or 25, well, it doesn't make sense to do the ones if we're already at 25. We should just start at 25, right? There's no point to go any lower than that. So this saves us a little bit of a step. There is more to come on that. I will return to that, but it starts us in a place where it actually makes sense to start. And that's the point of that, okay? So I is less than equal to amount, right? Because that is our goal. So that's what we're aiming for. And of course, I plus plus, okay? So inside of here, we take the array. We take the array of whatever I is, and we set it to this is a weird one, but hear me out. It's going to be I minus coin. Okay. So what we've done here is we've set whatever I is, and in fact, we start off at 1, right? Like it can't be 0 because there is no 0 in this array. So coin is going to be 1, which means that this is 1, but 1 minus the coin, which is 1, is 0. And the 0 index, right? Because that's what we're doing. We're setting an index, okay? And I actually did this wrong. This is plus equals, sorry, since I'm here. But we are adding whatever this index is to the current value. Now the current value is 0 because we set the 0 here. So for 1, right, we would go I minus coin, which is 1 minus 1. That would be 0. So we add whatever the 0 index is, which is 1 right here, to whatever the current index is, which is 0, and we get 1, right? Hopefully like that feels very confusing. We're going to come back to that in a second, but at this point, we go down here and we wrap this up and we say array amount, and it works, okay? Now again, how does it work, right? I tried to explain it. Let me try to explain it again. So I have a comment because comments help me visualize a little bit better, okay? So let's say we're starting out with 15. 15 is the magic number that we want. Could be 3 nickels, but we need all the variations. So what we do is we set up an array, which is all zeros, and then immediately set that first one to 1. How many items are in here? Well, there's 16, right? The length of this array is 16. We did that up here. It would be 15 plus 1, which is 16. There's 4 and another 4 and another 4 and another 4. Okay, so 16 in total, which means that we are there. And then we drop into our loop. So our coin would be the pennies, which is 1. And we go, okay, this index, which is currently 0, plus index minus coin, right? So that would be this. So 0 plus 1 is 1. 0 plus 1 is 1, 0 plus 1 was 1, 0 plus 1 is 1, all the way down to 0 plus 1 is 1, and we're done, right? So technically what we're doing is setting, with that initial value, we're setting each value to 1. We're going to come back to that in a second because there's a little thing that they never talk about in the examples that I've seen, and I think that we can improve on this and save ourselves a little bit of looping, right? You might already see it, but stay with me. We're going to come back. But pennies, we did it. We set everything to 1. Why? Because that's all we can do, right? And then we drop into the nickels, which is 5. Well, we skip because I equals coin. We skip the first 5 values. We immediately go to index 5, right? Which is technically the 6th item, but stay with me. And we start doing this thing again. So in this case, we go I, whatever I is, that would be 5, right? 5, minus the value of the coin, which is 5, which is technically 0. So we're here, right? This brings us over to this, and we add it. So 1 plus 1 is 2, and we go 1 plus 1 is 2, and so on, etc. And then we get to the 10, right? And 10 minus 5 is 5. So it's 1 plus 2 is 3, and so on, etc. So technically for the nickels, every 5 we add 1. Okay, hopefully that makes sense, right? Then we go to the dimes. So the dimes start at 10, which means that we skip all of these and all of these, and we go right to this, okay? And same thing, it's technically still 3 right now, right? It's the 3, and the index is 10. So 10 minus a value, which is 10, is 0. So that would be this index, which is 3 plus 1 is 4, and so on, etc. And then when we get to 15, well, that was already 4. And if we subtract 10 from 15, we get 5, which is 2, which is 4 plus 2 is 6. And we keep going like this, right? Like we don't use the quarters in this example, but each time we build it out. And then the final step, so for 15, the final step is to peel off that last value, because that last number is how many times, how many different versions of exact change we can give. Okay. So in the case of 15, there is 6, right? Hopefully that's making sense. Now, I did mention that regardless of anything, right? Like whatever amount we put in here, when we do the pennies, we're looping over from the 0 index to whatever the amount index is, all the way over here, and setting everything to 1. Well, how silly is that? I mean, we do that every single time. If we did 99, we would basically be doing 99 loops just to set these values to 1. When what we really could be doing is setting this to 1, getting rid of this array set, because that doesn't matter anymore. And then right here, we could either delete the 1, or we could come down here and go slice. Oh, do it right. It needs to be a dot slice on 1. It'll be 1 to whatever is left. So it gets rid of the 0 index. Brilliant. And from there, it should still work. It absolutely does. But we've saved ourselves this entire loop, right? Because why? Well, why would we need to? We still have to do this loop. So we've say, like, as an example for 99 again, we've saved ourselves 99 loops, but we still have 99 minus 5, right? So 94 loops in the second. And then, of course, whatever 94 minus 5 again, right? So 89 would be for the dimes, and the quarters would be a lot smaller, right? So we can actually save ourselves some time by doing this sort of stuff and commenting it out. But this is the solution. And it's been out there for so long that this is pretty much like, if you search on this, if you AI this, if you do whatever you're going to do, it's going to be some version of this loop. So why fight it? We may as well just do it. There's no point in trying to reinvent the wheel, right? There's no point in reinventing the wheel. And in fact, one thing that I was thinking of early on was I wanted to get the largest coins. So if we had, say, 41 cents, well, that's one of each coin, right? 25 plus 10 plus 5 plus 1, that's 41. So we would get all those. And then trying to reduce down, so going to 5 and going, okay, 5 can be broken into 1s, and then 10 can be broken into 5s, and then 1s, and then trying to break it down. But it ends up being messy. And as an example to that, you take 50, right? 50 would be 2 quarters at the largest amount, starting with the largest amounts. Well, if you break 2 quarters down, you get 4 10s and 2 5s, right? Because it's 2 10s and a 5 for each quarter, two dimes and a nickel for each quarter. Well, what about the 5th dime, right? Because you can also do 5 dimes. My code wouldn't have accounted for that if I had taken that route, if I hadn't done the research. So again, there's nothing wrong with Googling and trying to find it. I actually started out by going, is there a formula for this? I wanted to know if there was a formula for this. There absolutely isn't. We have to do this dynamic programming thing to sort it out, which means that we're in it for a ton of work, unfortunately. But in the end, it gets it done. Do I like that we're building out every instance between 1 and 99 as an example? No, I don't. But thankfully, it's only to 99, and the coins are only 4, so the looping should be pretty fast, right? Again, this is the most common solution. So today, this is my solution. Again, not every solution, just hopefully one good solution. If you like it, if you hate it, if you went a different way, I want to hear all about that inside of my comments. Also, let me know what you think about how I explain this with the comment. I think it helps. It definitely helped me. I hope it helped you. And keeping in mind that this was exact change, I will see you in the next one.